This is the last of our differentiation rules, the quotient rule. We'll look at recognising when we use the quotient rule, when we've got a quotient with a function of x over a function of x, and we'll learn how to find the quotient rule in the formula booklet or to remember it and then apply it in answering some questions involving differentiating quotients. This is what it looks like in the formula booklet in function notation. So if we start off with y equals u over v as our quotient, then the derivative dy dx equals v du dx minus u dv dx, all divided by v. Although the quotient rule looks complicated, if you're methodical about it, like we did with the product rule, it's not nearly as bad as it looks. Write out your u first, write out your v, differentiate them, write your du dx and your dv dx out, possibly even write out the v squared and then apply them to the formula. Here's a little helpful way of remembering the quotient rule. The derivative is equal to ho d hi minus hi d ho all over ho ho. That's where we start off with the quotient hi over ho. So in your function, the top equation is your hi, the lower equation is your ho. To find your derivative, you multiply your ho by the derivative of hi, minus the hi multiplied by the derivative of ho, and then divide by ho squared. Maybe that'll help you remember it. Here's some examples. So in this first example, we're starting off with the quotient 6x over x plus 3. You can see that these are two distinct functions of x in the numerator and the denominator. So we let u equal 6x, v equal x plus 3. Then we work out our du dx, which is obviously 6. And our dv dx, which is just 1, isn't it? Because the x differentiates to 1 and the 3 to 0. And then simply write them in the formula. The little dot here just means multiply by. So we've got x plus 3 times 6 minus 6x times 1. And then x plus 3, the v, squared at the bottom. Sometimes this is enough, but most of the time you will be required to factorise. You can see here if you multiply out and simplify, you end up with just 18 on the bottom because the 6x and the minus 6x cancel. And then usually we would just leave this in this form at the bottom, but it's multiplied out there just for illustrative purposes. Second example, we'll start off with 5x minus 2 over x squared plus 1. You can see here that our u is 5x minus 2, our v is x squared plus 1, so our du dx will be 5 and our dv dx will be 2x, and we can see that applied here. Again, the simplification here and final answer in this form here. If you need to, pause the presentation and spend a bit of time working through these examples so you understand them fully yourself.